Hello friends, welcome back to our channel. So today we'll see one more concept in compiler design, that is specification of tokens. Specification of tokens. So whenever the term called as a tokens, that means we are discussing about the lexical analyzer, the part of the phase of lexical analyzer. So because the output of the lexical analyzer will be the tokens, as we discussed in our previous sessions, right? Now here the question is, how can we specify a token? So mainly this token can be specified by using a regular expression. So by using this regular expression, any token can be recognized, right? For example, if you consider an identifier, the compiler will decide the rules of identifier. What are the rules? So we know that the rules are identifier should start with either underscore or a symbol, but not the numericals, and followed by it can have any number of alphabets or any number of numericals, right? And except underscore, it should not accept any special symbols. So these are the some rules we are given, and if all these rules have been matched with the some lexeme, then we can say it as an identifier. So we are just extracting each and every lexeme from the programming instruction, and we are checking with these regular expressions, and if it satisfies, we are considering it as a tokens, whether they are comes under the identifiers or keywords or operators, etc, etc. So the main specification for recognizing this token is a regular expression. And how this regular expression can be achieved? So with the help of a language. So how the language can be represented? With the help of set of strings. And how these strings will be represented? So it is a set of alphabets. And how these alphabets can be represented? These are nothing but symbols. So this is the hierarchy, how we can specify a token. So we in order to specify this token, we should know about the symbols, and by combining a group of symbols, we call it as a alphabets or strings, grouping of alphabets. And grouping of these kind of strings we call a language, and we'll decide the regular expression for this particular language, right? Now we'll see one by one. So what is a symbol? So the first one is a symbol. So if you are watching this session, you might be learned about the automata theory. So in that automata theory, we have learned everything. So these are all the similar terms. So not a similar, the same terms which we have used in the automata theory. So usually it is called as a ATFL or theory of computation, or FLAT. In some universities it will be calling as FLAT, formal languages and automata theory, right? So once again we'll revise. If you are not aware about this one, so please visit that one. I'll post in the description section. So please visit that one. And even in this session also, you will be understanding what about the symbols, alphabets, strings, etc, etc. So here the symbols are anything can be considered as a symbol. For example, 0, it's a numeric symbol. 9, it's also a symbol. Small a, capital A, at the rate, dollar. So all these are the different symbols. Okay, different symbols. And usually all these we can call them as a alphabets. That means a single symbol, we call it as a alphabets. So you can know that 0 and 1 will be the binary alphabets. Okay, small a to z, these are the lowercase of alphabets. Similarly, some capital A to capital Z, these are the uppercase alphabets. So some 0 to 9, these are the numerical alphabets. Similarly, at the rate, dollar. Okay, all these are some symbols, special symbols, right? So all these comes under the alphabets. Individual symbol, a single symbol, we call it as an alphabet. Now, alphabets. And now, what is a string? So a string is a group of characters. We are calling it as characters, and here we will call it as a alphabets. So coming to the second category, that is strings. Strings. So strings are a group of alphabets. A group of alphabets. So more than one alphabet we can call it as a string. For example, so let it be A, B, C. This is one string. Similarly, A, 1, 2, C, 4. This is another string. So A, B. So one more string. Okay. So like this we can combine a group of characters and we can call. So here usually the characters can be called as an alphabets. Okay. So a group of alphabets we call it as a strings. And here we can perform a few operations on strings. So what are those operations that can be performed on strings? So the first one is a prefix. Prefix means, so what I mean, the starting letters of the string, starting alphabets of the string. That means we can usually call as a leading alphabets. Okay. So for example, A, B, C, D. So this we call it as a prefix, and this we call it as a suffix. That last characters. Okay, the last characters we will call it as a suffix, and the first characters we call it as a prefix. Because see, if you consider this A, B, C, D, so these are a group of characters, and we can say this as a string, right? So consider this as a string. That means we are prefixing this particular string with this particular A. So that's why we are calling it as a prefix. For example, one more, A, B, C, D. If you consider this one, C, D, as a string, then A, B will be the prefix, because the string is started with the A, B. So like that, the prefix means starting characters. Starting characters. Okay, so here for example, if you consider the string as, see, I'm writing my name Sundeep. So if the string is Sundeep, okay, now the prefix will be see, first one is an empty string. Okay, first one is an empty string. For example, here the empty string is represented as a epsilon. Okay, empty string is represented as epsilon. So we can say that epsilon is nothing. Okay, epsilon is a nothing. So if you write this one, it doesn't sense difference if you prefix with a epsilon. Yes. So epsilon dot Sundeep is nothing but Sundeep itself, because this is an empty string. And don't use this, don't imagine that this is a product. So if epsilon represents the length 0, then 0 into string is 0. So that's not a 0. So if you consider x as a string 1 and y as a string 2, if you write string 1 plus string 2, which is a concatenation, that becomes x and y. That becomes x, y. So here, even though we are writing x, y, it doesn't represent that it's a product. It is a concatenation. So always the concatenation will combine the strings. So here also the epsilon dot Sundeep. So here what is the prefix? For example, if you consider this as a string, what's the prefix? Obviously epsilon. And the same thing, you can represent it as Sundeep concatenated with epsilon. So it also does not change anything, right? So obviously, if you consider this as a string, what will be the prefix? So whatever the characters we are writing here. So this is the characters. If you consider UNDEP as a string, what is the prefix? It is a yes. If you consider NDEP as a string, what is the prefix? SU. If you consider DEP as a string, what is the prefix? SUN. So like that, the prefixes will be like this. Okay, all the leading characters, the characters starting from the string. So if you consider the part of string, the remaining strings on the left side will be the prefix. And similar to prefix, there is a one more operation called suffix. Suffix. So quite opposite. That means ending characters. Ending characters. For example, if you consider the same thing, so let it be the string. So ending characters. So here again the string, let us take the same thing. Okay, now suffix. What is the suffix? What is a suffix? You can say that if you are writing this one, so if you consider the complete name as a string, what is the suffix? Epsilon. Okay, these are the ending characters. If you consider Sundeep as a string, what is this one? Epsilon. Epsilon will be the suffix. And if you consider the complete epsilon as a string, what is the suffix here? Sundeep. So obviously, coming to the prefix and suffix, the first two elements will be the epsilon and that particular string. And see now here, if you consider P as a substring, okay, this one as a string, what is the suffix? It's a P. And if you consider this one as a substring, SUNDE, then EP will be the suffix. And if you consider only SUND, then EEP will be the suffix, and it will be move on. So this is nothing but a suffix. The ending characters or a trailing characters, we can call it as a trailing characters, leading or trailing. So leading, we call it as a prefix, and trailing we call it as a suffix. And now there is one more operation, that is a substring. So here we have to consider both the leading and trailing characters. That means a combination of prefix and suffix. So how the substring will be calculated? So you can say again here the string is the same thing. See Sundeep, and consider once again we'll take the same thing, epsilon into Sundeep dot epsilon. You can write it, no issue, no? Right. Then the substring will be, so if you consider UNDE as a string, okay, so we have to eliminate the suffix and prefix. So eliminate the suffix and prefix, you can write it as, so here the substring will be UNDEEP. That means the string which is available in between the prefix and suffix. Okay. So in between, I am writing shortcuts by W, right? It's a between. In between prefix and suffix. Prefix and a suffix. So that will be the substring. So here you can observe, see, the first thing we'll see. So here if you observe epsilon and epsilon will be the prefix and suffix, you can simply write it as a Sundeep. Okay, and if you imagine S and P as a suffix and prefix, it will be UNDEEP. And if you consider SU as a prefix and P as suffix, then obviously it will be NDE. Okay. So here up to E only, right? So if you consider S and EP, so S as a prefix and EP as a suffix, then it will be UNDE. So that means, and there will be a lot of substrings. There will be a lot of substring. Okay, so you can also go with the SUN as a prefix and EEP as a suffix, then the substring will be only D. Okay, so in this way we have to calculate the substrings also. And similarly, the next operation is concatenation. So concatenation means adding two different strings. So just now we have seen, if X is a string 1 and Y is a string 2, so if you concatenate S1 plus S2, that means both the strings, then we'll get the product, that means XY. We'll get the XY as a product. So that is the concatenation. Usually it will be represented with a plus symbol. This is not an arithmetic addition, this is a concatenation if we perform this plus in between the strings. Just remember that. So this is the second level. Now we have to move on with the languages. What are the different languages? So what is meant by a language? So a collection or a set of strings from the alphabets is called as a language. We'll write here. So next one is language, which is nothing but set of strings. From the generated from alphabets. For example, if the alphabet, we usually call it as a sigma is equal to alphabets A, comma B, and this language, the language L will be all the strings which are generated with the help of these alphabets. That means A, B, AB, AA, AAA, ABB, BB, okay, ABA. So whatever the strings we are generating from these alphabets, everything comes under the language. So this is a language. Okay, now we want to know the operations of this particular language. So the operations. So first one is a union. So we know that a union operation will combine both the languages. For example, if S is having some language, some A, comma B, and T is having some language called C and D. Okay, now the union operation S union T will be the combination of both languages A, comma B, comma C, comma D. That means whatever the alphabets available or whatever the strings available in this particular language and whatever the strings available in this particular language, both comes with the union operation. So union, right? And the next one is an intersection. So intersection here is nothing but a product of two different strings. So for example, the same thing we take S is equal to A and B and T is equal to C and D. So then S intersection T will be a product of the combination of both S and T. See, A product with C, A product with D, B product with C, B product with D. So this is somewhat different, and this we call it as an intersection. So combining both the languages, the product of both the strings. Okay, so this is an intersection. And the next one is a closure. So usually we call it as a clean closure. So clean closure means it is represented from 0 onwards. Okay, so there are two things. One is a clean closure, another one is a positive closure. So starts with 0 and here it starts with 1. Okay, and one more example, one more difference, it represents with a star. It represents with a star, and here it represents with a plus. With plus. So make a difference. So if it is having a star, then it is called as a clean closure, and if it is having a plus, it will be calling it as a positive closures. So I'll represent this one. So it can be written as sigma star union from 0 to infinity. Okay, 0 to infinity. L naught, sorry, here you can write it L. Okay, L. So which is nothing but simply, so L naught, comma, L1, comma, L square, comma, L cube, comma, and so on, L of infinity. Okay, L of infinity. And here we will be getting it as a 1, comma, if L is having the alphabets A, comma, B, then it will be, so all these are the unions, different unions. Okay, so, or if you consider it as A for simplification, so it will be A, and so on. This will be the clean closure. And if it is a positive closure, then sigma plus U1 to infinity L. That means, so what will be getting? So L1, L2, L3, and so on. So that means we will get A. So that's the difference. It will start from 0, and here it will be starting from 1, and here it will be represented with a star, and here it will be represented with a plus. So these are the different operations that can be performed on a languages. So union operation, intersection operation, a clean closure, and the positive closure. Right? So hope you understood these languages. Now we'll move on with the regular expression. So just now we have seen, if we define a language, okay, if we define a language, we can set a pattern. So if the lexeme identifies with that pattern, then we can say it as a token. So the next one is a regular expression. So usually it will be having some pattern match. So pattern matching. Okay, pattern matching will be there. I'll tell you one example. For an identifier. Right? And we know that identifier should start with either underscore or alphabet. So the first should be either underscore or alphabet. That can be A to Z or capital A to capital Z. So always it starts with this one. Followed by multiple. We can have A to Z, capital A to Z, 0 to 9, underscore. Right? So this matches an identifier. This shows that it should only start with either alphabet, underscore, or lowercase alphabet or an uppercase alphabet. And here you can simply use a star. That means it can repeat multiple times. Okay, and followed by multiple alphabets or multiple alphanumeric. So it can have multiple alphabets or multiple digits or any underscore symbol also. Right? So this type of pattern matching will be there, and based upon this pattern matching, the regular expression will be worked. And one more thing here. So see, the union of R1 and R2. Here R1 or R2, assume that both are the different regular expression. this will also gives a regular expression. And similarly, closure, both closures of R1 and R2 will also gives the regular expression. So we can combine, okay, we can union the regular expressions and we can get a final regular expression. So simply imagine that regular expression means a pattern match. So which should satisfy by the lexeme. So if it's satisfied by the lexeme, then it will be categorized into some tokens. Right? So these are the different ways we can specify a token. So a token can be specified majorly by using the regular expression, and regular expression will be represented with the help of a languages, and a language will be formed with the help of set of strings, and a string will be formed with the help of symbols, or we call it as alphabets. Right? And we have also seen some operations on strings and as well as operations on some languages. Right? So I'll stop here and hope you enjoyed the session. And if you are having any query regarding this one, feel free to post your doubts in the comment section. Definitely I will try to clarify all your doubts. And if you really enjoyed my session, like my session, share my session with your friends, and don't forget to subscribe to our channel. Thanks for watching. Thank you very much.